بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Our topic for this week is algorithms and programming languages. The objectives of this topic, we will define the concept of algorithm, and then the importance of these algorithms. Also, we will identify the steps to design and evaluate an algorithm. Then we will define the concept of programming, explain the link between the programming languages and the algorithm. Also, we will explore the programming languages and differentiate between machine language and high-level language. And finally, we will differentiate between two standard approaches in programming translation, which are interpretation and compilation. قبل ما نبدأ حابة أدي example بسيط يورينا الفكرة العامة للتوبيك in general. الآن لو هعرف الالجوريثم in simple way هقول الالجوريثم is a method or a way to complete or to accomplish a specific task. يعني أي method الآن هتكون عبارة عن steps or instructions. Instruction of what or how to do something. So this is an algorithm. We are using the algorithms concept or the similar idea of algorithms in our daily life. يعني, for example, if you are driving a car and you reach a traffic light, you will follow specific instructions. You will check the light. If it is red, you will stop. If it is green, you will go, and so on. This is the steps of the driving algorithms, for example, or checking light, traffic light. هنحاول نحط هذه steps على شكل flow chart. Let's say you are driving and you reach a traffic light. First thing you will do is checking the light. I mean the color of the light. If the color is red, you will stop. The answer is yes, you stopped. And every moment of time or every time you will check the light again. If the color is red, you stop, and again. Suppose this time the color changed. Is the color red? The answer is no. We'll go to the next step. Is the color yellow? No. You will go to the next step. Is the color is green? Yes. You will go to the step process called go. Go, for example, go process here, we're calling another method or another driving algorithms, and continue driving. So in general, we call this flow chart, we call this chart a flow chart. This is the way we design an algorithm. We cover all the possibilities and all the steps to accomplish this task, a specific task. For example, here, traffic light. In daily life, you know this and you do this. لكن إحنا الآن بنتعامل مع ماشين. Same thing. هنسوي نفس الخطوات. هنصمم الفلو شارت. بدل عينك وحواسك حيكون في كاميرا وسنسورز، بدل دماغك حيكون في بروسيسور وميموريز. المهم حنستبدلك بماشين. هنصمم الفلو شارت هذه للماشين maybe in more details. And then we will describe this flow chart into statements, English-like language. Called pseudocode. After a designer or a researcher finished designing the algorithm, زي ما قلنا flowchart, pseudocode, then a programmer will rewrite this pseudocode into high-level language. High-level languages like C++, Java, Python. طبعا البروجرامر بيستخدموا specific tools for writing this code, and these tools also will be used for translation. عملية translation هذه هنا هتكون فيها two approaches زي ما حنشوف بعدين. إما أستخدم compiler أو أستخدم interpreter. المهم الزيروز وانز هذه تطلع عندي أو الأوتبوت هذا عبارة عن machine language، نسميها machine language. لأنها executable by the machine، يعني the machine can understand zeros and one، وبالتالي حتنفذ instructions. هذا فريم عام أو general view for our topic. ونرجع الآن للسلايدز حقتنا. In this slide, we have a problem. We want to check the weather. In general, to solve any problem, we need to understand what is the data we have and what exactly the required output. Anyway, this is not a complete example. Just for simplicity, we have some assumptions. We assume a good weather is no rain and no wind. Also, a good weather is rainy but not hot. So, according to this, the solution as you see in this chart, we will check the rain first. If it is yes, we will check the temperature. It is not hot, this is a good weather, otherwise the output will be bad. If the answer for the raining is no, so no rain, we will check the wind. If it is no, the answer is good, and otherwise the answer is bad. The science of computation is about solving problems, so it is based on algorithms. هنا definition بسيط للalgorithm. So an algorithm is a step-by-step sequence of instructions for carrying out some task or to accomplish a specific task. العملية هذه عادة بيقوم فيها programmer وبنسميها programming process. So the programming process is the process of implementing an algorithm or implementing algorithms. The programmer usually will create an algorithm to solve a problem by creating the flowchart and the pseudocode. Then translate this code into programming language, usually high programming language that can be translated into zeros and ones, a form that computer can understand. In the real world, in our daily life, we are surrounded by algorithms. In fact, the algorithms make the technologies work. ما في شيء يشتغل بدون algorithms. Examples اللي عندنا هنا مثلا when you are watching a video across the internet, you are using hundreds of algorithms. مثال you are using audio and video compression algorithms. الغرض من هذه algorithms to reduce the size of the data, and therefore the transmission of the data will be much faster. Another example, when you use a navigation app like Google Maps to figure out how to get to a specific location, you are using routing algorithms. The routing algorithms check real-time traffic data with previous stored data about many factors like the roads, the traffic devices, and more. These algorithms were designed in order to calculate the best route to your destination. What about NASA? How they arrange the solar panels on the International Space Stations, and when? The answer of this question is they use an optimization and scheduling algorithms. These are very complex algorithms to accomplish tasks that cannot be done by human. In biological science, many algorithms in computer science are applied to solve biological problems. And nowadays, new algorithms are being designed, for example, for molecular structure that are the core of disease-fighting drugs. Also, genetic algorithms for prediction of inheritable diseases, and so on. This is really a promising discipline. Now you can understand that the use of algorithms is not limited to the domain of computation. Any set of instructions can be considered as an algorithm. Simple, like preparing a recipe, or more complex, like navigation to your house or to a specific location on a map. Actually, there are many unfamiliar tasks in life that we couldn't complete without instructions. يعني إحنا عادة ما نحتاج إلى instructions عشان نحصل على instructions محددة عشان نحصل على نتائج مطلوبة والنتائج المطلوبة. عادة ما يكون في كذا طريقة، كذا أوامر إذا أو بشكل عام كذا algorithm يحل المشكلة. So we may have different instructions to solve the same problem. The most important thing here is this instructions or this algorithm, these instructions or this algorithm should be effective and correct. عشان يتحقق هذا الشيء لازم تكون الأوامر تبعت الألغوريثم قابلة للتطبيق. يعني الشخص اللي حينفذ يفهم ويقدر على تنفيذ هذه الأوامر. So an algorithm should be understandable by the executor. So the person who will perform the task or the person who will perform the task can understand the problem. For example, a recipe written for a master chef will look different than a recipe written for a college student. هذا example عندنا لو فكرنا فيه من ناحية الكوركتنس. مثلا ال recipe for cooking cookies, good cookies are enough for a student, but not enough for a chef. ومن ناحية أخرى ما حنقدر نكتب tools or ingredients غير متوفرة عادة، وبتحتاج مثلا من الطالب إلى وقت ومجهود عشان يوفرها، لكنها بتكون عادة موجودة عند الشيف لأنه هو يهمه في النهاية الكواليتي. So the specification of the two recipes are different. The two recipes for cooking cookies, but the specifics are different. لو فكرنا برضو في هذا الموضوع من ناحية الكمبيوترز هنلاقي إنه الكمبيوترز زي ما مكتوب هنا are more demanding. So computers are more demanding regarding algorithm specifics than human. إيش يعني هذا الكلام؟ يعني data و instructions لما أكتب algorithm للكمبيوتر must be accurate in detail. Now we will explore the designing and analyzing of some computational algorithms. Before this, we talk about that algorithms is about solving problems, and whether we are solve a problem in a computer or any other abstract science, we use Polya's problem-solving process. This process consists of 4 steps. First, understand the problem. We need to understand what we are looking for. What are the components and the data of the problem? We need to determine the assumptions and the variables required to solve this problem. Second, devise a plan. Come up with a way to solve this problem. What your equations? What the rules? You can draw a diagram and refine this diagram into flowchart. Write your pseudocode. So this is your strategy, your algorithm. Third step, carry out the plan. Implement your plan. Implement your algorithm. If it is a software, it's about programming process. Write your high level language program or write your high level language code. Finally, examine the solution. Verify, check is your answer is correct, check that you use the data, test the performance, evaluate your solution, and so on. Now we want to solve a problem, finding the oldest person in a room full of people. First, we need to understand the problem. We are looking for the information of the oldest person. And what are the data? We have a room full of people. We need to determine our assumptions. First, we will assume that all people are normal. Everyone can give their real birthday. And we assume if two people with the same birthday, they are the same age, including the oldest. So if we have more than one oldest person, any one of them is okay. يعني يهمني في موضوع الage، ما يهمني أشخاص نفسهم بقدر ما يهمني the age of the oldest person. So we will consider two versions of algorithms to solve such a problem. The first algorithm, it's very simple. الفكرة هنا إنه هرتبهم في line or queue وأبدأ أسجل معلومات أول شخص باعتباره أكبر عمر عندي، وأبدأ بعد كده أقارن واحد واحد، أسأله عن معلوماته، لو عمره أكبر أسجله وأشطب اللي قبله، لو أصغر ما أسوي شيء، أروح للي بعده. لما أنتهي راح ألاقي إنه مسجل عندي أكبر شخص بالعمر. That's all. So نرتب هذا into steps. First, line up people along one wall or a queue. Then ask the first person to state her or his name and birthday and write the information down on a piece of paper. Step 3, for each successive person in line, يعني for next person in sequential, and for each one in the line, ask about the person for his or her name and birthday. If the stated birthday is earlier before than the birthday on the paper, يعني أكبر من اللي مكتوب عندنا, cross out the old information and write down the name and birthday of this person. لما أخلصهم هلاقي نفسي في الأخير when reach the end of the line, the name and birthday of the oldest person will be written on the paper. طيب هطبق هذا الألغوريثم على الإكزامبل اللي عندي. أول ستيب هأسجل كريس أول واحد باعتباره oldest person. بعدين أبدأ أقارن واحد واحد. اللي بعده أصغر ما راح أسوي شيء. اللي بعده بات أكبر فراح أشطب القديم وأسجل بات لأنه أكبر. اللي بعده أصغر ما حسوي شيء. اللي بعده ما حسوي شيء. اللي بعده جاك كمان أصغر ما حسوي شيء. اللي بعده جون أكبر راح أشطب القديم وأسجل جون لأنه أكبر. اللي بعده تشارلز أصغر ما حسوي شيء. اللي بعده خلصت انتهيت. حلاقي مسجل عندي جون the oldest person which is a correct answer. حلاحظ في الالجوريثم هذا عشان أخلص الجروب اللي عندي أو أخلص الداتا اللي عندي احتجت أعمل 8 comparisons. يعني كل واحد هعمل له تقريبا operations كاملة. لو فرضنا إنه كل واحد هياخد مني 1 minute معناه to finish this algorithm I need 8 minutes or required 8 minutes. لو كل عملية comparison تحتاج 5 seconds معناه the required time for this set of data for 8 people will be 40 seconds. إذا لو عندي 1 million persons هيكون عندي 5 million seconds. Okay, the second algorithm is simple algorithm but slightly complicated than the first one. الفكرة هنا إنه راح أصف الناس وأطلبهم يكونوا أزواج اثنين اثنين. يعني لو عندي عدد فردي من الناس راح يبقى شخص واحد لوحده، مو مشكلة، هيبقى لحد الخطوة قبل الأخيرة. إذا راح تتكون عندي أزواج وحطلب من كل زوج يقارنوا أعمارهم مع بعض، الصغير يطلع يبقى الكبير، وأكرر طالما عندي أكثر من شخص. أزواج تكون، كل اثنين يقارنوا بعض، الصغير يطلع ويبقى الكبير and so on. بالأخير راح يبقى شخص واحد عندي هو الأكبر عمرا. لو رتبت هذا الكلام into steps هنقول first line up the people. Second, as long as there is more than one person in the line, عندي أكثر من شخص. Repeat. Have the people pair up. If there is an odd number of people, the last person will be without a partner. No problem قلنا. As each pair of people, ask each pair of people to compare their birthdays. Request the younger of the two leave the line. Repeat. When there is only one person left in the line, the person is the oldest. Algorithm 2, on the same data set, we have group of 8 people. زي ما قلنا في البداية line up and pair up people. عندي 8 هيصيروا أزواج، كل اثنين مع بعض هيكون عندي 4 أزواج. كل زوج هيقارن نفسه مع بعض، الكبير يبقى والصغير يطلع. إذا simultaneously هتصير comparison between them، وحيبقى لي 4 أشخاص، هيبقى عندي زوجين. إذا كريس and كيلي من راوند 1 هقارن، هيبقى كريس حتطلع كيلي مثلا. بات and جان هيبقى معايا بات هيطلع جان and so on. In second round again pair up and compare. إذا كريس مع بات هيبقى معايا بات، وجاك مع جون هيبقى معايا جون. In third round هلاقي بس عندي one pair هقارنهم، هيبقى الأكبر اللي هو جان. So جان is the correct solution. نلاحظ في الألجوريثم هذا إنه خلصت أو عملت solving the problem only in 3 rounds. If each round required 1 minute معناه I can finish the algorithm in 3 minutes only. لو كل راوند تحتاج 5 seconds معناه إنه the problem will be solved in 15 seconds only. طيب لو العدد عندي أكثر من كذا، لو ضاعفنا العدد، يعني بدل 8 people عندي 16. From first round هنعمل pair up وحيطلع الصغير ويبقى الكبير. إذا from first round هنتخلص من نص العدد، من 16 حيبقى 8، نفس العدد اللي معانا الآن. إذا زاد كم راوند؟ راوند واحد. إذا لما أضاعف عدد الانبوت أو الداتا سيت حقتي هيزيد بس 1 راوند. إذا لو عندي group of 16 هيكون عندي 4 rounds to solve the problem. Each round 5 seconds mean I need only 20 seconds to solve this problem. Why we need algorithm analysis? In our previous example, we have 2 different algorithms to solve the same problem, which was finding the oldest person. As we see, or as we have seen together, both algorithms or the 2 algorithms have completely different approaches. So how can we tell which is better, which is the right one to choose? The answer is not always is correct. It depends upon what features are most important to the application. كلنا نعرف إنه any application consists of group of algorithms work together. So some features are more important in an application than other features. إيش هي هالفيتشرز هذه؟ The most important features of algorithm, correctness and efficiency. إيش نقصد فيها؟ correctness to make sure the algorithm works inside the application and the algorithm is clear to the application. Usually this can be tell أو ممكن يتأكد يعني عن طريق testing, checking the results and so on. بينما efficiency is more complex. Efficiency can care about time or space and required effort from the machine. Usually عادة يعني حيكون في trade off between space and time in most algorithms. For that we need to analyze the performance, calculate the complexity of the time, calculate the complexity of the space. In our slides we are caring more about the time complexity. To analyze the time for algorithm 1. إحنا شفنا كيف نعمل comparison for each person in algorithm 1. إيش يعني؟ يعني the amount of time to find the oldest person is proportional to the number of the people. If the comparison required 1 minute. So for 100 persons, we need 100 minutes to solve the problem. If the comparison required 2 seconds only. So for 100 persons, we need 200 seconds to solve the problem. So proportional to the number of the people. When you double the amount of people, the time needed to find the oldest person will also be doubled. So لو عندي 200 person, I will need 400 seconds to solve the problem. Algorithm 2, we saw how algorithm 2 allows simultaneous comparisons. يعني بيقارن في نفس الوقت. وبالتالي the time needed to find oldest person is proportional to the number of routes. كان عندنا for example 8 persons احتاجنا only 3 rounds. طبعا ممكن حساب number of rounds mathematically بس هو خلاص محسوب عندكم. مهم تعرفوا انه number of rounds حيساوي logarithm base 2 of number of people. So logarithm base 2 of the number of people. And if we double the amount of people, كان عندنا 8 وصار عندنا 16. شفنا كيف إنه the time needed to find the oldest person increase only by 1 round. 1 round equal to cost of 1 comparison. ليه؟ لأنه عندي 100 comparison هيتصلحوا أو يتنفذوا في نفس الوقت 2 seconds. يعني خلاص كلهم هيخلصوا في 2 seconds. عندي 20 comparisons هيخلصوا في 2 seconds. عندي واحدة comparison هتخلص 2 seconds. So the cost of the round equal to cost of 1 comparison. Here just a note عشان لا تلخبطوا بين algorithm and logarithm. Algorithm بحاضر عشان logarithm the exponent to a base to produce a number. يعني الأس اللي حرفعه للبيز يديني ناتج. log 1000 to base 2 equal to 10. log 1020 or 24 to base 2 equal to 10. ليه؟ لأنه 10 the exponent الأس للأساس. إذا 10 exponent to base 2 equal to 1024. هذا بالنظام binary system. okay? binary system base 2. إحنا نستخدم كهيومن بحياتنا نستخدم decimal system النظام العشري من 0 إلى 9 10 digits. عشان تفتكروا ناخذ example بسيط log 10,000 بالنسبة للنظام حقنا decimal كم حيساوي؟ يساوي 4. ليه؟ لأنه اللوج اللي هو 4 is the exponent الأس. إذا 10 أس 4 يساوي 10,000. نفس القاعدة same. الالجوريثم 2 number of rounds حيساوي log base 2 number of people. إذا لو عندي 1000 شخص 1010 1020 1024 إلى 1024 لو عندي 1000 شخص كم comparison كم راوند ححتاج؟ 10 rounds. إذا 10 rounds to solve the problem to find the oldest person. إذا the cost of the comparison 2 second إذا ححتاج 20 second to solve the problem. algorithm 1 1000 شخص ححتاج 2000 second to solve the problem. 1000 شخص ححتاج 2000 second to solve the problem. algorithm 2 1000 شخص ححتاج 20 second to solve the problem. ليه؟ لأنه the cost of a comparison 2 seconds. Here we can compare the performance difference in terms of time between algorithm 1 and algorithm 2. So assume that a comparison costs 5 seconds. So to check one person, to check a person, we need 5 seconds. For algorithm 1, time is proportional to number people. So 100 people معناه for each one I need 5 seconds. So 5 seconds multiplied by 100 equal to 500 seconds and so on. لو عندي 1 million people معناه 5 multiplied by 1 million equal to 5 million seconds. Days, weeks. For example 2 قلنا إنه time is proportional for number of rounds. So number of rounds حسبناها mathematically قلنا إنه number of rounds حتساوي logarithm base 2 for number of people. So log base 2 for number of people. So 100 person, that means number of rounds will be a log of 100 base 2. ما في داعي تحسبوها هنطلعها من التابل. So log 100 اللي هو عدد people هيساوي 7. So 7 rounds. Each round costs 1 comparison. Each round costs 1 comparison and the cost of comparison is 5. So 5 multiplied by 7 equal to 35 seconds. And so on. لو عندي 1 million people log 1 million base 2 equal to 20. So 20 multiplied by the cost of the comparison equal to 100 seconds to solve the problem. In computer science, we call the amount of time you need to run a program big O notation. So big O notation is a term means time you need to run a program. When we classify an algorithm as big O notation n, big O notation n means the program requires time proportional to the size of the problem. Number of input equal to number of participants. So with big O notation in algorithm, doubling the problem doubles the work, or doubling the input, the size of the problem doubles the work. Example, algorithm 1. Algorithm 1 is big O notation n, and the 100 participants, I need 100 comparison. And the 1 million participants, I need 1 million comparison. Where big O log n algorithm means this algorithm requires time proportional to the logarithm of the problem size. So given big O notation log n algorithm, doubling the problem size or the input, just add a constant amount of work. Example, algorithm 2. Algorithm 2 classified as big O notation log n. So باختصار big O notation يعني time complexity. كم احتاج وقت عشان البروجرام هذا يخلص أو الالجوريثم هذا solve the problem. Number of participants هو نفسه size of problem هو نفسه number of input. Now we will look at two examples of the most popular computer science algorithms, which are searching algorithms. So searching, a common problem in computer science, involves storing and maintaining large amount of data and then searching the data for particular values. This slide is about the importance of designing a systematic approach to search for data. By logic, when searching randomly, you can search forever and you can get nothing. Even if you found something, it's likely to take a long amount of time. Anyway, because of the large amount of data in industry and almost in every application, computer scientists designed and continue designing hundreds of algorithms to search, sort, and store data. The two algorithms you will learn are sequential search, general purpose algorithm, but relatively slow. The second, binary search, restricted use, but fast. Sequential search is an algorithm that involves examining each item in a list in sequential order until the desired item is found. Simply check each item one by one. So the steps of sequential search. First, we will start from the beginning of the list, and for each item in the list we will repeat the following. Examine the item. If the item is the one that you are seeking or the one you are looking for, then you are done. If it is not, go to the next item. And these two steps will repeated maximum for the number of the items. If you reach the end of the list and you haven't found the item, then the item wasn't there. As we can see, it is very simple algorithm and guarantees that you will find the item if it is there. but not practical, especially in large databases. For worst case scenario, you may search the entire list and entire list because the item either at the end of the list or it is not there. Binary search involves continually cutting the desired search list into half until the item is found. يعني every time or every round we will cut this list into half again and again. The algorithm is only applicable if the list is ordered. عشان كده بنقول restricted algorithm. في condition لازم يتحقق عشان أقدر أستخدم الباينري سيرش إنه الليست تكون sorted in ascending order from the smallest to the largest or from A to Z. عندنا هنا example هنشوفه. So we have a list of records or items sorted, so we can apply a binary search. Initially, the entire list is a potential range for the item we are looking for. يعني ممكن يكون item at any location or index of the list. So in round one, we will take the item that we are looking for and compare it to the middle point. The middle point here at index 7, which is 47. So the middle point is less than the point that, or the middle point is less than the item that we are looking for. So the item has to be in the right side of the list. The item is greater. Then we will repeat this process again. So round 2, the potential list now is the right side only. So we will search only on the 7 items. The midpoint, as we can see, at the index 3. We will compare now our item 72 with the middle point. The middle point is greater than 72. So 72 has to be in the left side this time. And at round 3, we'll find that the potential list consists only of 3 elements. We'll repeat again the same process. So comparing our item with the new middle point. 64 is less than 72. So 72 has to be in the right side. In round 4, the list were cut down into only one item, and our item is not found. So this is a scenario of worst case of binary search. It is obvious that this algorithm is can be classified as all-notation login because we have 15 items, and the worst case scenario is 4 rounds. Log 15 equal to 4. Next slides represent the binary search steps. So at the beginning, the potential range in which the item can occur is the entire list. And we will continue searching as long as there are items in the potential range and the item hasn't been found. So we will repeat. First, examine the middle entry of the potential range. If the middle entry is the item you are looking for, then you are done. If the middle entry is greater than the desired item, then we will cut or reduce the potential range to these entries left the middle. If the middle is less than the desired item, then we will cut or reduce the potential range to those entries right the middle point. As we saw in the example, by repeating cutting the list into half, binary search can find the value very quickly. For the search algorithms analysis in sequential search, the worst case scenario when the item we are looking for at the end of the list or not found in the list at all. So as a result, when we inspect or compare, we need to compare the whole list. So the amount of work required is proportional to the list size or the problem size. Therefore, sequential search is classified as big O notation in algorithm. For the binary search, the worst case scenario when we have to keep cutting down again and again the list till we get down to single entry. So each time we inspect an entry, we rule out or get rid of half of the remaining entries. The amount of work required is proportional to the logarithm of the problem size or the list size. Therefore, binary search is classified as big O notation log n algorithm. At the end, we have a simple example. Suppose that we have a phone book of 300 million entry. So sequential search algorithm requires at most 300 million inspections, while binary search requires at most 29 inspections in case the list is ordered. Otherwise, we need to apply an efficient sorting algorithm before using binary search. This slide uh, will describe the link between algorithms and programming. Programming is all about designing and coding algorithms for solving problems. يعني pseudo code of the algorithm will be written again in high-level programming language, so it can be executed by the computer. The high-level programming languages are constrained languages more than human language, which can be frustrated. But in general, programming now is much easier than 50 years ago. بس لمحة تاريخية إنه يعتبر computer ENIAC the first computer that can be programmed by connecting wires. أما الوضع الحالي الآن كلنا بنستخدم البيرسونال كمبيوترز. البيرسونال كمبيوترز designed using Van Neumann architecture. Van Neumann architecture, the computers can or could be programmed. This is Van Neumann architecture. In a simple description, consists of 4 parts: input devices, memory, processing unit, and output device. So when we wrote the code of the algorithm, the code loaded into the main memory or the RAM, so it can be executed by the computer, and the input and output devices will be used to communicate with the outside. الصورة هنا الثانية بتوضح لي ENIAC computer where few people only able to perform computation using this complex computer. This figure shows the classification of uh, programming languages, which are machine language, assembly language, and high-level languages. Machine language is the first programming languages, and it consists of instructions that correspond directly to the hardware. So it deals directly with the physical component, including main memory registers, memory cells, CPU. It is very low level of abstractions written in binary systems, zeros and ones. For that, it is tedious and error prone, impossible to understand and debug. This is an example of machine language code. Assembly language evolved from machine language. Assembly language substitutes words for binary code and becomes slightly friendly and more easier to remember when use the words. But still, it's a low-level programming language, and you need to understand a lot of hardware operation to code in assembly language. This is an example of assembly language code that use a simpler in converting to machine language. In 1950s, high-level languages were introduced. These languages allow the programmer to write a code closer to the human language, as opposed or opposite to the previous machine language or assembly language that mimicking hardware operations. High-level languages are much or more natural way to solve problems where the programmer doesn't have to understand the hardware operations or to write his code. Another thing or another important feature of the high-level language programs that they are machine independent, means they're able to run on a variety type of computers, a variety type of hardware, and not restricted from this side. There are many high-level languages. This just an example for JavaScript and C++ code. When we write a code in high-level language, it must be translated into machine language so the computer can execute the program. Using a high-level language, the programmer is able to reason and think at a high level of abstraction. The programming process becomes more easier. The programs that written in a high-level language must translate it into machine language so the computer hardware can understand and execute. There are two standard approaches to program translation: interpretation and compilation. يعني الآن كل الأكواد والبرامج اللي مكتوبة باللغات العالية الهاي ليفل languages زي السي بلس بلس والجافا والسي شارب لازم تترجم إلى zeros and ones so can be executed by the computer. Now we look at analogy of translation speech from one language to another to explain the two approaches of programming translation. First one is an interpreter, which can be used to provide a real-time translation. So the advantage of this is immediate translation, but the disadvantage, if you want to hear the speech again, you must interpret all the speech over again. The second approach analogy is a translator, translates the entire speech offline. The main advantage of this approach, once the speech translated, it can be read or listened to over and over again very quickly. The disadvantage must wait for the entire speech to be translated. So we wait for a large amount of time for translation, but only for one time. Here you can figure out some main differences between the two approaches. For the interpreter, it is immediate translation, statement translations. Also, we can say it is direct translation, nothing between them. And for waiting, it is a short time waiting for each statement, but if there is any need to re-translate, it will repeat again the process of translation, and the overall time of waiting will be large. For the translator, there is a waiting time, a large waiting time in the beginning of the translation, but when the translation complete, the speech is accessible very fast. Second different is we can say there is some kind of object between the translator and the person or the user, whatever. Also, the overall time of translation is less than the interpreter because it is only in the beginning. So, for the interpretation approach in the programming translation, we use interpreter tools to translate and execute high-level language statements. So the interpreter will read a high-level language statement and immediately translate statement by statement before processing the next one. JavaScript is an example of an interpreter language that mainly used to design web pages and web services. So every time you open a web service or a web page written in JavaScript, it will be interpreted statement by statement into or within your browser. So the overall time of translation is very large. For the compilation approach, the translation tools known as compilers. A compiler can translate the entire high-level program code into equivalent machine language executable file that can be executed directly on the computer. The languages that use compilers like C languages, C, C++, C#, are common in commercial software. This table describes the difference between the two translation approaches, the compiler and the interpreter. Compiler will scan the whole program at once and produce a program machine code executable file. يعني هيطلع لي program من عملية translation مكتوب بالماشين كود، بينما الانتربتر ما بيطلع لي بروجرام مكتوب بالماشين كود، لا بيعمل translation statement by statement. الكومبايلر في بداية عملية translation will takes time, large time to analyze the source code، لكن في النهاية خلاص حنعمل مرة واحدة، إذا ال overall execution time is fast. بينما الانتربريتر كل مرة statements، لكن مع الوقت will add up overall execution time will be slow، لأنه كل مرة أصلا تفتح البرنامج بنعمل له translation. الكومبايلر generate intermediate object code لأنه زي ما قلنا بيعمل application، فبيعمل كمان intermediate object code to link with the other executable file، بالتالي يحتاج more memory. الانتربريتر ما عنده أي intermediate object file، so it's memory efficient. الكومبايلر لما يعمل compilation يكون في error في البروجرام ما يقدر يعمل translation، ما بيطلع ال errors إلا في النهاية، so debugging is hard. بينما الانتربريتر will stop على أول غلطة، على أول error حيتوقف، بالتالي من الأسهل إنه الواحد يعرف مكان الغلط ويصلحه. الكومبايلر اللغات زي السي والسي بلس بلس والسي شارب والجافا شارب to create desktop applications and commercial applications، والinterpreter زي البايثون والروبي والجافا سكريبت to create web services web applications. This figure shows the execution process to analyze the source code in both approaches.